Okay. All right, can you people hear me? All right, okay, fantastic. Today I'm presenting everything around GSM. And I will start with explaining GSM a little bit, and then we start focusing on the security of GSM. And later on I'll introduce some device that you can use to receive GSM traffic. And ultimately I will tell you how you can crack GSM traffic, receive and crack, and hopefully listen to it. And then I'll try to get you excited joining our project. First of all, our project is public. Our project is public, and everyone is welcome to join. We have a wiki online where you can read what we are doing, and it's a whole group behind this. I'm just presenting it, okay? So everything was not engineered by myself. And ultimately, yeah, I would like to get you excited and get you to join us, our effort. Okay, let me start. First off, why are we doing this? We are doing this because no one else is doing this. This is always a good reason. If no one else is doing it, it's probably hard because no one else has done it. And we like doing hard things. We like doing things that no one else has done. We also do this because probably companies wouldn't like this. The mobile operator wouldn't like this if other people could intercept their traffic. And that's usually good motivation as well. If a big company doesn't like it, there's always something to get. And also I'm very happy to give this talk in Austria, because if you've heard, in Germany there's some new laws that makes this kind of talk and this kind of speech very dangerous to do and very, very problematic. Because in Germany they decided instead being able to look at the problem and talk about the problem, they decided you're no longer allowed to look at this problem, and the companies get away with having faulty security, and ultimately you suffer from this. So I'm very happy to be here and give this talk in Austria, which is always a nice thing. Okay, let's start. First slide. Well, we talked about this already. Let's talk a little bit about GSM. GSM is the largest mobile network. There are over 2 billion subscribers on GSM. This is 2 billion, okay? This is, I think that might be more subscribers on GSM than people have running water at home. So it's a lot of people on there. Let's talk about the GSM network. Very complicated map. It will get easier in a minute, but ultimately what you have on the left side is a mobile phone. Everyone has a mobile phone. The mobile phone talks to the base station. This is the air interface, and then it goes into the normal landlines to the central database. And you see a lot of interesting things here. You see AUC, which holds all your key information. You see routers and base station concentrators and all this. So what you have to realize is that your mobile phone is like a network plug. It's a network plug into the mobile operator's network. And with this network plug, you can do more things than just doing phone calls. You can query the database, you can retrieve location information, you can change location information, you can change location information of other people. You can do a lot of funny things, but we'll get to that more later. And because it's an air interface, it's more or less like the old times when you had hops instead of switches. You hear everything. Whatever this person over there receives, you receive as well. It's a broadcast, okay? The radius of a GSM mobile phone is up to 30 kilometers. And this is 30 kilometers radius. So in both directions 30 kilometers. So if you have a good receiver, ideally you can receive from 30 meters this direction or 30 meters this direction. That's very, very long. I mean 30 kilometers, you're already in the next town from here, okay? It's very, very long. I'll talk later about why this is reduced and practically not possible. But this is receiving. This is when other mobile phones are transmitting. Obviously you can transmit to the moon if you like. You only need an amplifier. You know, if you amplify a lot, you can transmit to the moon. You can tell a base station in Rome from here that you are now in Rome. Okay? I mean, it only depends how much power you put in. Okay, ultimately base stations are clustered into little cells, and they don't overlap these frequencies. But this is just to give you an idea. Each cell is maximum of 30 kilometers. In city centers, they are much more reduced, and you will see this in a minute why. This is a picture of a base station. You see them when you walk around. You see them on the rooftops, and usually they go into 3 directions. Each is a directional antenna of 120-degree angle. So they have 3 antennas per base station. And this picture taken in the UK, there's a base station in here as well. Okay, there's a base station in this tree. It's a 100% artificial tree. They are doing this in the UK because people start complaining about the massive amount of base station in their garden. So, well, I don't know. Okay, let me talk a little bit about phone. How does a phone work? And our first approaches. A phone these days consists of two processors. And a phone is an amazing device. It's a very fast processor. It's 200, sometimes 300 megahertz, 32-bit ARM architecture, okay? So you can do a lot of stuff with it. They do a lot of processing. And they come with two processors. They come with a baseband processor, which does all the GSM networking stack. And they come with the application processor. The application processor is usually what you see. You know, it's your calendar and your SMS and all the fancy stuff. And the baseband is just a pure stack. Okay, our first approach. We wanted to receive GSM signals. So we looked on the internet and see what's there. And what we found is that there's a Nokia phone, and this is a lot of phones from the Nokia DCT3 series. We choose the 3310, that was shipped for 2 years with debug symbols enabled. So Nokia shipped this phone with debug symbols in the phone between 2000 and 2003. So all these phones have debug symbols, and you can exploit these debug symbols. You can have fun with them. You can turn your mobile into a trace mobile. So connect it to a PC, you configure it in a special way, and all of a sudden you receive all traffic that is sent from the base station, all traffic. Okay, so you see, for example, traffic that is sent to your friend on the beacon channel, on the broadcast channel. And you can analyze this with the PC, and this helped us a lot. I bought my phone for €1 on eBay, and the shipping cost €12. So shipping was more than the phone itself. Then there are other ideas how we thought, okay, how can we intercept traffic? Texas Instrument, who's the world leader in these OMAP chips for receiving for processing GSM signals, they have target boards and development boards, which are rather expensive, $2,000, $3,000, and they are rather hard to get to. But you can program these boards, there's Linux running on there, and you can get access to the baseband chip, and you can access to the traffic that is coming to you, and you can also send your own traffic. Then there's a company called PicoChip. They are doing base stations for picocells, for little companies who want to put up their own base station in their own room, in their own office. And they are software-based, and they are having development boards as well, so you can use these as well. And then there's wireless 3G for free. And this is another company who has 100% software implementation of a base station running on real-time Red Hat. And yeah, you can modify it and start sending and receiving information. But we decided to use the USRP. The USRP is the Universal Software Radio Peripheral. It was developed by Matt Etters, and he released, I think, 3 or 4 years ago. And it's a device that can receive any kind of traffic from 0 to 5 gigahertz. Any kind of frequency. And it's 100% software driven. You connect it with a USB cable to your computer, and you receive the signals, you define the frequency you want to tune in, you define the bandwidth, and all of a sudden you receive all the IQ signals, and you do all the demodulation on your computer. And there's a new project, a new radio project, who wrote a lot of tools and a lot of blocks to process this data. And we are using the same thing. Now, let's go into GSM signaling. GSM signaling works on different frequency bands and depends where you are, if you're in America or in Europe. But a famous one in Europe is the GSM 1800 megahertz band. And a GSM phone is either sending or receiving. It's never doing the same thing at the same time. Okay, this makes our design much simpler because we either have to concentrate on sending traffic or we can swap on transmitting traffic. We don't have to deal with both at the same time. And sending and receiving, it's also separated on a different band. They're 25 megahertz apart. So we can tune, when we're on one certain frequency, we know on this frequency there's only traffic from the base station, and when we're on a different frequency, we know from this frequency there's only traffic to a base station. Okay, the USRP costs $900, okay? It's not expensive. And considering the euro at the moment, it's really cheap. At the limitation of GSM, and then I also explain why 30 kilometers is not really possible. Limitation of GSM is that at a maximum 1,000 people at the same time can do a phone call. If there are more 1,000 people, the frequency band can't handle it. Okay? So what they do, Obviously, there are more people at the same time now in Vienna doing phone calls. There are more than 1,000 people. So what they do, they make these cells smaller and smaller. They make them 2 kilometers small. They limit the transmitting rate. And then in a 2 kilometer cluster, 1,000 people can do a phone call. So if 1,000 people in a stadium, they all do at the same time a phone call, the network is jammed, and you get this famous network busy thing on your mobile phone. Maybe one of you had it already. That's a limitation. Okay. I talked about this already. It's either sending or receiving. The beacon channel. The beacon channel is a broadcast channel. The first thing your mobile phone does, it listens for all messages sent to everyone. It's like on a network sending to everyone. It's there as well. It's sent to everyone analyzes it, and at some point the base station says, I want to speak to this specific mobile phone. And then the mobile phone says, okay, this is me, what do you want? And the base station says, yeah, I would like to send you an SMS. Why don't you go in a different channel? And then all the communication happens on a different channel. But everything that is sent over the beacon channel, you receive as well with the Nokia phone, okay? So you receive, for example, information, this mobile subscriber just entered your cloud, you're receiving cloud. Or this mobile subscriber just left your cloud. This mobile subscriber just is at the train station or somewhere else. You see whenever someone initiates the calls, whenever someone receives the calls, when someone sends a text, receives a text. You see the kind of encryption that they're using, and all this kind of meta information you get for free, unencrypted. Okay, some more facts. One burst lasts 156.25 bit. If you're a computer scientist, you start vomiting when you read a quarter bit. But when you're an RF engineer, you say, okay, it doesn't really matter. And really, it doesn't really matter. Okay, that's enough of the facts. This is an example output of the Nokia Trace Handy. So what we did, we connected the Nokia Trace Handy, and we sniffed or traced the traffic received by the mobile phone while receiving a text message. And this is a good example how you can see what's going on, what's happening on the beacon channel. What you see here is the base station asking for any kind of mobile phone with this specific temporary mobile subscription identification to respond if it's there. So, hello mobile phone, are you there? And then the mobile phone, then the base station says, okay, I would like to do something with you, please go on a separate channel. And it assigns a separate channel. All this information is public. It assigns a separate channel. It tells the mobile station the channel hopping frequency and the channel hopping algorithm to use. And all this is all public, okay? The next message it sends, okay, who are you anyway? And it says, yeah, my type of identity is IMSI. I would like to get your IMSI, your mobile subscription identification. And he says, okay, this is my IMSI. The mobile phone responds with the IMSI. And this is something fascinating, because if you read the GSM standards, it says the IMSI should never be transmitted over the network. Okay? So this was the first trace that we did. The first trace. And what we see is the IMSI being transmitted over the network. So this gave us hope. We just started with GSM. Okay? We started with GSM this year in 2007. This was the first program we ran, and what we see is already shit coming out of this. Okay? So, well, great. Let's continue. I told you the cipher to use. The base station says, okay, A5/2 is available, which is the weak encryption, and also A5/1 is available. The mobile phone should use a stronger one, okay? It might not always do so, but it should. The base station sends a random number to the mobile station, and the mobile station will encrypt this random number, generate an address, and then send this address back to the base station. The base station can then verify that this is really the authentic subscriber he wants to talk to. So address is sent back. All this is clear text, okay? And then the base station says, okay, let's start ciphering, but please also include your EMI. This is not just the subscription identification, this is now also your equipment identification. And obviously that's sent in clear text as well, including the software version. So everyone basically knows what kind of phone you're using. Also something that shouldn't be clear text on the network. Okay, let's see. GSM security. You know this picture? GSM network. Now, there are certain ways how you can attack a GSM network. how you can intercept traffic. Obviously, the most obvious way is you have the key already. Okay, easy to do. We don't talk about this. Another way is you just go to the base station. Only the interface is encrypted. As soon as it hits the base station, it's all clear text. It's sent over clear text, digital lines, throughout the network. So someone with access to a base station, and they are quite easy to access. If you look out of the window,